Good morning to one and all present here. Today I am going to present my research topic, green synthesis of TiO2 nanoparticles using Hybanthus Ennespermus leaf extract and its application in photocatalytic dye degradation. Factory discharge contains a high proportion of potentially active toxic materials. These chemicals are mainly dyes and pigments. Dyes and pigments are predominantly used in different industries, and a reasonable amount of these compounds go to environment through industrial effluents. As these compounds are toxic and carcinogenic in nature, their impact on the environment is a major concern. A number of physical and chemical techniques such as filtration, precipitation, coagulation, absorption, and oxidation have been pursued for elimination of these toxic compounds. The photocatalytic oxidation technique has a number of preferences over traditional techniques because it has less energy requirement, no requirement for sludge disposal, and complete degradation of pollution pollutants. Photocatalytic oxidation, which is one of the viable and developing methods utilized for destruction of toxic pollutants and dyes for recent years. A photocatalyst is a material that can accelerate the process without being exhausted after being triggered by absorbing a photon. In this process, four significant factors are getting involved, such as light energy is absorbed to produce electron hole pairs, excited charges are separated, electron holes are transferred to the exterior of the photocatalyst, charges on the layers are used for oxidation reduction reaction. The photocatalytic technique is now mostly used in detoxification of contaminated water, such as wastewater produced by the paper, printmaking, dyestuffs, and galvanizing industries. In the present study, green synthesis TiO2 is utilized. The aqueous extract of Hybanthus Ennespermus and was employed as photocatalyst for rhodamin B. Synthesis of TiO2 using Hybanthus Ennespermus leaf extract. 10 ml of the aqueous leaf extract of Hybanthus Ennespermus is added to 20 ml of 1 mm TiO2 at 25 degrees Celsius under stirring condition for 3 hours. After 3 hours, the color of the extract of the TiO2 nanoparticle changes to green. And the figure shows the schematic illustration of the green synthesis of TiO2 nanoparticle using aqueous extract of Hybanthus Ennespermus. Actually, the leaves were collected and they are washed several times with double distilled water to remove the debris present in the leaves and flowers, and it is dried. The dried powder is taken and it is boiled with water for 30 minutes for 3 hours, and after that the leaf is extraction is obtained, and it is filtered, and the extraction is obtained, and the extraction is treated with TiO2. These are the SEM and XRD images of the TiO2 particles prepared from Hybanthus Ennespermus leaf extract. And this is the this is the effect of time with rhodamin B concentration. Here the dye used here is rhodamin B. So rhodamin B is used as a model pollutant, and the various amount of the TiO2 nanoparticles are added to dye. Here 5 milligrams per liter, 15 milligrams per liter, 30 and 40 milligrams per liter of TiO2 nanoparticles are added to dye, rhodamin B. And as the time increases, the dye removal also increases. And as the concentration of the TiO2 nanoparticle increases, the dye removal is also increases. Degradation also increases. If you increase the concentration of the if you increase the concentration of the TiO2 nanoparticles, the dye removal is also high. More amount of the dye is removed from the wastewater. And this is the effect of pH on the dye removal. Okay, so it works well on the acidic pH, and as the dye concentration increases, the pH of the solution increases, the dye removal will be very slow. And this is the effect of temperature. The ideal temperature is 1 not sorry 50 degrees Celsius. This is the UV spectra of rhodamin B and treated rhodamin B solution. Here RB diet, when TiO2 green TiO2 nanoparticles are added to the solution, the photo degradation increases. Okay, so number of dye particles removed are high. This is the kinetics of photo degradation of rhodamin B at various temperatures. And this is the kinetics of TiO2 photo degradation of rhodamin B with various initial concentration. At 10 milligrams per liter, more amount of dye is removed from the effluent. So as the concentration of the dye increases, the degradation will be slow. This is the catalyst reusability. We can use up to 7 cycles, and the maximum number of recyclability is 98%. So these are the conclusions. TiO2 was successfully fabricated by environmentally friendly and low cost green method using Hybanthus Ennespermus leaf extract as reducing agent and titanium dioxide as precursor materials. TiO2 nanocomposites showed high efficiency for treatment of wastewater containing mixture of dye. More than 95% of dyes were degraded in 120 minutes. It was found that there was no loss in catalytic efficiency of the prepared TiO2 catalyst after recycling it for 7 times. In this simple, cost-effective, time-saving and environmental friendly synthesis technique is used in various applications. Thank you.